What is up, mathies? Welcome back to another episode of Math with Dr. Math. And today's big idea is, do you ever feel like you're just going through a math class and just trying to memorize this long list of rules, right? So I know we've been there. I know I've been here. And so today what we're going to do is we're going to look at this question right here, or a comment that someone had in terms of how do I memorize all these? And that's the wrong idea right there. We don't want to memorize them. And in math, what we want to do, which is always better, is use what we already know and use our thinking and some creativity to get where we want to be. All right, what the heck are you talking about? All right, so check this out. All right, you don't even have to be in a trig class to understand what we're doing here. All right, so we have some rules here. And what's nice often in math classes, right, is we have this long list of things that we can, that maybe you're asked to memorize or to know, right? And what I do is I always, right, as I got better at math, is I would pick two or one of these rules, and I would ask myself, based on, say, these two rules right here, can I come up with all the other rules? Right? Because it's much easier to understand and to learn these two rules, and then from here, get everything else. So let's go ahead and do that today. All right. So what I'm going to ask you to do is I'm going to ask you to say memorize, and then we'll look at some examples. The first two, and how do we use these first two rules to get everything else? All right, because it's much easier, and the same idea you could apply it to all areas of math. Okay, so let's go with tangent. All right, let's start with that third one. So tangent of negative t. All right, so if we understand tangent and understand our past, we know tangent is the same thing as sine, and the input remains the same, divided by cosine. Right, tangent is sine over cosine. Right, and now if we used our rules that we just looked at, we know what sine of negative t is. That's just negative sine of t. So this is the same thing as negative sine of t divided by, and then cosine of negative t, we saw right here that cosine of negative t is equal to cosine. So we're just going to set this equal to cosine of t. And now we know that sine divided by cosine, that's just tangent, and we have this negative sticking out in front. So our answer here is just negative tangent of t, right? Which is exactly what we expected, because that's what the rule stated. So again, what's nice, especially about a trig class, and again, I had a lot of people asking me to do a trig video. What's nice about this is we use two facts that we already knew, and we're going to use those two facts to build everything else, right? To get the rest of the results. That way, if you ever get stuck and you don't memorize these, right, you could just use what you already know to get that final outcome. All right, so hopefully that's making sense right there. Let's do another example. Cosecant right here. So cosecant, let me write this down. All right, let's use what we already know. Cosecant is the same thing as 1 over sine. Right? And remember, our input stays the same. So whatever's in here, right, that's exactly what is in here, right? So the input's the same. So these two things we already know from our previous lectures. We know those are the same. And what do we know about sine of negative t? Sine of negative t, this is one of the two things we set to memorize. That's just negative sine of t. So let's write that out. So this is 1 over negative sine of t, and as a result we know 1 divided by sine, that's cosecant, and then you're going to have that negative that's out in front. So this is just negative cosecant of t. Boom. And that's exactly what we expected. All right, so again, all we're using is our known two facts, and we're going to get the rest of these identities here. And I'm just focusing on these negative angle identities, but you could use this pretty much for all our identities, which is awesome. All right, let's do a few more here. Let me get a clean page for you. All right, so let's look at these two. So secant of negative t. All right, so secant of negative t. Well, secant we know is the same thing as 1 over cosine of negative t, right? That's what we already know. And so remember, our inputs stay the same, and if we go to the 2 that we should have memorized, cosine of negative t, that's the same thing as cosine of t. So boom, we get 1 over cosine of t. And what is 1 over cosine of t? We already know that's just secant. So this equals secant of t. And that's what we have right here, as expected. And what's nice, we could save some time for this one. Actually, let's just go ahead and write it out. Cotangent of negative t, that's the same thing as cosine of negative t divided by sine of negative t. Again, cosine of negative t is cosine, sine of negative t is negative sine. So let's go ahead and fill those in. So we got cosine of t divided by negative sine of t. And as a result, we know this is cotangent, and there's that negative that's sitting out in front. So that's why our answer is negative cotangent. And some of you might be asking the question, but the negative is in the denominator, Dr. Math. What do we do about that? Well, remember, as an example, if you have negative 1 divided by 5, that's the same thing as 1 divided by negative 5, which is the same thing as negative 1/5. So it doesn't matter where that negative sign is, as long as it's in there somewhere, right? So this is the same thing as cotangent divided by negative 1, which is negative cotangent of t, just in case you are confused about that. All right, so I just want to show you a quick little example here because a lot of people, they feel they have to memorize all these rules. And what I always teach is understanding. So if you understand these first two, you could come up with the rest of the rules from those two identities right there. All right, so why are these rules even important, and how do they help us out, right? So let's finish off with this. Let's plug in a number, right? So let's plug in your favorite number for sine, which is probably 30 degrees, right? I think that's a fan favorite. So let's plug in 30 degrees, right? And so we know sine of 30 degrees is 1/2, all right? So according to this rule, if I wanted to know sine of negative 30, right? So if I wanted to know sine of negative 30 degrees, so we'd be going the opposite direction there, right? Instead of actually drawing everything out, drawing my triangle and going through that business, right? What we could do is we could say, okay, according to this rule, right, my answer is going to be the same thing as if I were to plug in a positive 30, with the exception of the sign is going to be the opposite sign. So whatever sine of 30 degrees is, I'm just going to change the sign, and there's my answer, right? So instead of having positive 1/2, I'm going to end up with negative 1/2. Oops, let me draw that negative sign again, because, right, what we do is think of this negative sign as coming out there. It's not really coming out, but we could think about it right there if that helps you out. All right, mathletes. So again, all you would do if you want the negative of angle, you just find the positive angle, and then whatever that answer is, boom, take the opposite sign, and there you have it. It's that easy. So again, these negative angle identities are very useful once you're doing these calculations. All right, mathletes. Hope you're having a great day. Don't forget to subscribe, like, and we'll see you mathletes in the next video. Peace. All right, mathletes, thanks for watching. And again, if you like this video, we have some other videos that we think you might enjoy. Thanks for watching, and we'll see you guys next time.